Hi, my name is John. I am the director of the X-ray facility at Emory University in Atlanta, Georgia. Emory is a private university situated outside Atlanta in the greater metropolitan area.
What are the crystallographic challenges you face?
So we work with a wide variety of materials that include highly reactive intermediates, strongly absorbing polyoxymethylates, and optically active pharmaceutical compounds. The reactive compounds sometimes even decompose while we're trying to collect the data on the diffractometer. So we have to collect the data quickly and efficiently. I am particularly interested in electron density studies of catalysts, and we need to collect high resolution data for these compounds.
What encouraged you to consider a Rigaku Oxford diffraction system?
At the outset, we wanted to get a system that could collect data on very small crystals and also collect the data quickly. I was interested in the kappa geometry and the motorized detector. We also need to collect data to determine absolute configuration of light atom organic molecules, and we wanted to do that in a short time. And we also wanted a strong source and a sensitive detector for electron density studies.
Which configuration did you choose?
So we chose a 4-axis system with a dual microfocus source and a HPAD detector.
Why did you select that configuration, and what specific device was that?
So we chose a Synergy S system for Emory because we realized that it was superior to all the other current X-ray systems in terms of the diffractometer design, the ultra-sensitive detector, and its highly focused beam. The high-pix detectors are sensitive, low noise, and high-speed devices with much higher dynamic range, no oversaturation and very short readout times. We also chose the system because of the dual microfocus source with the multi-layer optics, because it has a much greater flux density than the standard sealed tubes. So this system gives considerably better data for small crystals. And it was also clear during the demo that the system had a superior design to the competing systems.
Thank you. What have your experiences been thus far?
So our experiences have been overwhelmingly positive. Each time we get a sample in the lab, we look forward to collecting data. Collecting data is fun and a pleasure. The students and researchers really enjoy using the system, especially the "what is this" feature. So organic chemists or chemists typically bring down a new sample from the lab, and we are able to do a structure in something like 5 minutes in a very short time, and so they can see there and then what their structure is, and it's quicker than doing an NMR, and that feature really impresses the researchers. They're really happy that they can get their results back in such a short time.
Thank you. This is your first Rigaku Oxford diffraction system. Can you comment on the transition from the software used previously to using Chrysalis Pro?
Okay. So I'm finding the Chrysalis Pro software a big improvement over the existing software. I really appreciate its intelligent design and workflow. The automated unit cell indexing the data collection strategies and the structure solution and refinement are intelligently designed and work really well.
How has the Synergy changed your workflow?
We are now able to do many structures in a day. In the morning, I can do analyze 5 different samples. So when we installed it in the lab, I was able to clean up a backlog of old samples and unfinished data sets. So that in that respect, it's really improved the state of unfinished data sets and crystals in the lab, and so it's given me time to do other things and manage other aspects of the lab, and give the students more time to work, run their own samples.
What do your colleagues think of the Synergy and the capabilities?
I think one of the things that appeals to them most is the "what is this" feature. They are really impressed that they can get a structure in minutes. I've been telling them how good the system is. They really appreciate being able to get results back very quickly. And the colleagues are very happy because they know that we have chosen the best system.
What do you think of the high-pix detector?
One of the most impressive aspects of the new system is our new detector. It is a solid-state detector. It's kept at room temperature, so unlike our CCD detectors, there's no water cooling. And the only detectable background noise on the detectors from the sample. So I noticed that the diffraction spots are very small with very low divergence, and the pixel size of the detector is very small. So we have been able to expose the detector for very long times without overloads. So the dynamic range is very impressive. So we can go from very low intensity to very high intensity on the same frame, and with count rates close to 1 million counts per second.
What's been the most challenging sample you've had on the diffractometer?
So I would say it's a compound with unit cell edges of about 90 angstroms. So the diffraction was very low, very weak, and the spot separation was the spots were very closely spaced. So having the motorized detector distance enabled us to measure that, and we were able to get quite a good data set for that. We are doing a lot of samples that we never used to attempt before. So one of the negatives is now I actually have a lot of data from poor quality samples now.
Do you expect to work those samples up then?
Yes, we do. But it takes a lot more work than what it ordinarily would have.
Thank you.
Yeah, thank you.